Hello and welcome to another video on Joe's Physics Corner. Today we're going to solve question A over here, which is from the 2015 PUPC. Okay, so first of all, let's read the question. Determine the distance from the wall, x over here, the velocity v here, and the angle theta from which the particle should be launched so that it lands a distance d away from the center of the wall and the energy used is minimized. Okay, so what we should focus on now at the start, we should focus on here. Energy used is minimized. So what does that mean? Well, to minimize energy used, it would be that we have to minimize our velocity over here. And from that, we could right away see that this particle over here, we're assuming that it has no volume. We're assuming that it's just a particle with no volume at all, no radius. And so it seems to be that this particle over here should cross both corners of the wall over here. Why? Because that would give us the least amount of change in gravitational potential energy, which would give us the minimum energy use, the minimum kinetic energy input to this mass over here. So when we draw this again, by this particle going through these points, these corners of the wall here, we could draw it like this. We have the platform over here, we have the mass over here, and we have the wall, here like that. The same wall. And when we say that the trajectory of this mass crosses both corners over here, and the flag is here, we know that mathematically, we could prove, but I guess you can all see that here, d should be equal to d over here. No, d over here should be equal to d over here because horizontal velocity is constant, so the horizontal displacement from this point over here to the flag, and the displacement from here to here should be same. And so this, which was originally x over here, we could say that x here is equal to d. So we did the first part of the equation. We determined the distance from the wall, x, and we have given x by d. And what can we do now? Okay, let's just set that aside. We're now calling it d, not x. What can we do now? Well, we could use Suvat equations, but we're not going to do that just yet, because there is an easier way to determine the trajectory of the path without doing Suvat, and that is just thinking it in mathematically. So we set this as the x-axis, it's different x. This is just the x-axis. I'm gonna call that big X over here, and call this the y-axis, because big Y. And then you could see that this is just a parabola with x-intercepts at 0, 0, and here 2d, 0, because the distance here is 2d. So what can we say? Well, we don't know the coefficient of x squared. We don't know that yet. So we could set that as m, and say we could x and x minus 2d, because the parabola over here has x-intercepts at 0, x minus 0, and 2d, x minus 2d. What else can we know from here? Well, we said that we have the gradient over here, so this was theta. Okay, and let's plot in some coordinates. We said that from this equation we could see that the distance from the center of the wall to the edge would be L divided by 2, because the entire length of the wall is L. And so if this is L over 2, we could say that this point over here would be d minus L over 2 times 2L, because height is the 2L, because height is 2L over here, 2L, and we assign this as d, so d minus L over 2. So this point over here would be d minus L over 2 times 2L. So I'll do that. And this point we could say it's d plus L over d times 2L, but I don't think that's necessary. Let me sit back down. And with this point, we could figure out what n is. We could say that, well, we could plug in these values into this equation and get 2L is equal to n times d minus L over 2 times d minus L over 2 minus 2d, which is d minus d minus d, which is minus d minus L over 2. And that's going to be equal to, when we, let's get the minus out of this equation, and we get minus m d minus L over 2 and d plus L over 2. And here we have opposite operators, and we could say that therefore it's d squared minus L squared over 4. Okay, and then we could rearrange this equation in terms of m. So we get m is equal to 2L minus 2L, the minus goes here. We divide both sides by minus d squared minus L over 4, L squared over 4. And so we get this equation over here. And we could, let's times both sides by negative 4. And we get 8L over, we change the direction of these by doing the minus and say L squared minus, L squared minus 4d squared. So we get m here. We can represent m here by L and d, which are both constants given in the equation, given in the question. So we get m equals 8L over L squared minus 4d squared. Okay, now what could we do? Okay, so we had this as theta. And theta we could say is, because it's the, okay, when you do that, for clearer explanation, tangent theta would be the gradient of y, of graph y, parabola y at x equals 0. So we could differentiate this equation. Let's leave m for now. So we said that y is equal to mx squared minus 2d mx. And so if we differentiate this first, we get dy over dx is equal to 2mx minus 2dm. And we said that now must equal to tangent of theta. Oh, no, wait, no, sorry. We got dy over dx like that. Now, we said that the gradient dy over dx at x equals 0 would be equal to tangent theta. And so dy over dx, x equals 0, is equal to, plug in m, we get rid of this, and we only get minus 2dm. And that would be, we have m over here. So we could plug in m to here, so we get minus 2d times 8L over L squared minus 4d squared, which is minus 16 dl over L squared minus 4d squared, and multiply both sides by negative, and we get 4d squared minus L squared. Okay, and then we said, because it's the gradient at here, which is tangent theta, we get tangent theta is equal to that. And so arctangent theta would be equal to arctangent 16 dl over 4d squared minus L squared. Okay, so what did we do up until now? We got x over here, we got d, and we got theta over here as arctangent 16 dl over 4d squared minus L squared. Okay, So that's done, and now the only thing left here is v. So let's erase all this.
No.
Erase all this. Tangent theta was that, so theta is arctangent minus 16 dl over. Oh, and we changed the direction, right? Okay, so we got theta like that, and let's erase all that. And now let's figure out what v here is gonna be. So let's just leave that. Wait, let's just get that like that from at the top. Okay, so now I think we should do suvat. Simple suvat. Let's just write what we have, suvat, and x and y. So what point are we going to use? Well, we already used this point, which means that using this point once more will not give us, would just be a repetition. It won't give us something new. And so we have to determine this point, the suvat at this point here, which is going to be max g gravitational potential energy. So this point here with max GPE, that's going to be the point in which we're going to apply suvat. Okay, so first Sx, what's going to be our horizontal total displacement? Well, that's going to be d over here. What's going to be our displacement in y? Well, we said that is 2L, but because of that, we don't know. We don't know the horizontal displacement, the vertical displacement at this point with maximum gravitational potential energy. And so that, let's just leave it blank. What's going to be u? Well, u is going to be, we call that v, so it's going to be the horizontal component of that, which is v cosine of theta, so katawa. And for now, we're just going to leave it like that because it's going to be too messy if we substitute this value into theta now. I'm just going to leave it like that, like this, v cosine theta for now. And then for y is going to be the opposite of this, so the perpendicular component of v to this, so it's going to be v sine theta. The final velocity is going to be same because we're assuming that air resistance is negligible, so it's going to be same as that. The final velocity in the y direction would be 0 because it has reached maximum height. So it's going to be, there's only going to be a horizontal velocity vector at that point here. And so it's going to be 0 here. The acceleration of x is going to be 0 because no air resistance, and the acceleration in the y direction would be minus g. I'm going to leave it as g because it's easier. I don't want to substitute 9.81. And because we assign this here as positive and that here as positive, because up is positive, we're going to say it's minus g, minus 9.81. And so, yeah, that's the variables we know up until now. And now it's pretty much done. Okay, well, how do we get t? Well, we have this equation over here, s equals ut suvat plus 1/2 at squared. When we represent that as in the x component, we get sx equals uxt plus 1/2 axt squared. And we know that ax here is 0, so we could ignore that and get t is equal to sx over ux, which is going to be sxd over ux, which is here, v cosine theta. So we get time is d over v cosine theta. Is that helpful for now? No. We're just getting we're just using the triangle, right? dvt. There's not much value in this, but now we could consider this part, the y component, and we could use the same equation. We have sy is equal to uyt plus 1/2 ayt squared. And no, wait. This, because we don't know sy for now, we can't use that. However, we could use, v is equal to u plus at, so vy would be equal to uy plus ayt. When we rearrange this, we get t is equal to v minus uy. That's going to be ayt, so we divide by ay to get t, which is going to be vy we said was 0. So 0 minus v sine theta, so just minus v sine theta over ay, which is minus g. So we get v sine theta over g as t here. Okay, I'm sorry the video stopped. I don't know why. Wait, where were we? So we got this as t here. And so let's just erase this for now. And what we could see here is that we have two different values for t. And what do we know? Well, we know that we are using the same time. Because we're getting the time from here to here, the time is going to be same. The time is going to be same. We always use when we are doing subat in school. We know that when we derive t, you can use this t in this equation over here, which means that the values for t, the different values for t here, is going to be same. They're going to be equal. So we have d over v cosine theta is equal to v sine theta over g. And so now we're done. We could rearrange this in terms of v by, doing cross multiplication and get v squared sine theta cosine theta is going to be equal to dg. And so we divide both sides by sine theta cosine theta. But before we do that, we can because we have such a long expression, for theta like that, we want to simplify this in some way. And we know we could do this by using the double angle formula. We could say, well, we know that sine of 2 theta is equal to, because it's sine cosine plus, when we have sine a plus b, we have sine a cosine b plus cosine a sine b. We could do the same thing here and get sine theta cosine theta, which is sine theta cosine theta, plus cosine theta sine theta, which is also sine theta cosine theta. And so we get here 2 sine theta cosine theta. We just erase this for now. And so sine theta cosine theta would be equal to sine of 2 theta over 2. Multiplying both sides by 2. And so we could say that this here, v squared, is going to be equal to, yes, it is equal to dg over sine theta cosine theta, but we also can say it's going to be dg over sine of 2 theta divided by 2, which is, when we multiply both sides of the fraction by 2, we get 2 dg over sine of 2 theta. Okay, so v squared is 2 dg over sine of 2 theta, and we're done. We could say v is equal to, it's going to be equal to the square root of 2 dg over sine 2 theta. We don't have much space. I'm just going to write it here. It's going to be equal to 2 dg over, you got theta over here, so sine of big equation 2 times arctangent, which is arctangent this is theta, so it's 2 times arctangent 16 dl over 4 d squared minus l squared And yeah, that is our value for v over here. So that's our v, that's our answer, that's our third part of the answer done. So we said x here was d, x here. What we noticed was that the distance x here and distance d here should be same. So we had x equals d. That's our first answer. We then had here d that equals arctangent 16 dl over 4 d squared minus l squared. That's our first answer. That's our second answer, and this here is our third answer. And so yeah, that's done. That is the answer to part A of 2015 PUPC. I believe it's question 4. Thank you, and see you in the next video. Thank you.